Pratima, you are not audible.
Yes. Hello, good evening. Welcome to today's session. Today we are going to take on to this topic of building LLM-based applications, which is very more important in terms of uh, understanding the LLM architecture, how you work out with the RAGs, and how in terms of prompt engineering. So these are all the few set of topics that we generally cover it out for today. So we start out with Yahya, who's going to take you through the complete overview of what LLMs are and how it generally works with the informed basics of the coding architecture. So from there, we move on to the very next topic of prompt engineering. So over to you.
Can you hear Pratima? If you are speaking, we can't hear you.
Actually, I'm not speaking. I'm just waiting for Yahya to start on to the slide.
Oh, okay. Sorry, just wasn't sure. Thank you.
Sorry, sorry. Sorry, I was muted. Okay. So we are discussing today LLM-based applications, and we'll go with the intuition, and then we'll try to understand the large language model, how to deploy it using APIs and custom deployments. So, so we'll going to understand how these LLMs are working and how you're able to understand the data. So the topic is basic intuition of LLM and how they interact with APIs. So we have a sequence of text that should be understood by the any model, right? So it may be any model. So we have a simple sentence. This has to be completed. So we need to understand the next prediction from the given word. So, but in order to predict, we have few classes, 50,000 classes of words. From this, we train a model and be able to predict the word which is missing. So this we can frame it as a ML problem, and this is a classification problem. So we have a data set of 50,000 classes, and we're able to train and able to fill the given blank of the next word for a one sentence. Okay. Similarly, we able to that able to able to find the next sequence of word using neural networks. So this is done with the probability. Okay, how we train the model and it able to predict the final output. So that is the blank cat like to sleep in the box. So similarly, we want to predict many sequence of words. Okay, so we have the context here in the purple, and with orange word, which is cat, we are trying to predict after each sequence. So when we train a large language model with vast amount of data, it able to it's try to predict complete set of sequence of the words from the given set of context. Okay, so similarly, it can also here we have been worked on a simple one sentence, but now we are trying to predict vast amount of given number of sentence or predicated words in in a bigger paragraph. Okay, so we are trying to predict much larger sequence of words from the given paragraph using longer sequence using LLMs. We can also use this for trying to go with the code completion also. So this also generates a many number of try to predict many number of given set of words in sentence completion has C. You can see here we are able to predict 6 to 7 number of words right from the given sentence. So this is done in multiple steps. In first step is try to predict one of the first occurrings, and then the next sequence is try to predict text, and then finally try to predict text. So you can see here, you slowly try to complete the given set of missing words from the given sentence, and it completes the sentence. So how is the large language model able to do it? Because they have been trained on large amount of data, and there have been number of parameters in the model, and the infrastructure for training has been very large. So they're able to understand the language, they're able to find the complex pattern relationship in the language, so that they're able to properly structure the information. Okay, so they use some kind of probabilistic machine to arrange the sequence whenever they generate the response. And this happens with the probability distribution of vocabulary of English language, and they will predict the next word. Similarly, we try to find out how the ChatGPT works now. Okay, so we have a chatbot. We have given some kind of recipes to this chatbot, or you can say this as a LLM. Okay, and then from this recipes book, I will be collecting and giving some individual recipes. Okay, and removing some unwanted data and giving individual recipes to this LLM. So this, after training or for further training, right, it able to give relevant recipes for the given input query, but it does not able to give recipe for the some of the given data. Okay, why it's not able to give it? Because it does not have the relevant data for this next recipe. For the first recipe, it able to generate the given recipe because it can find the relevant data from its training data set. So this kind of models you can call as generative pre-training models. Just a minute. Okay. 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 Is it available? Okay. So this is called as generative pre-training. So this is done with LLMs, which whenever we train with certain data set, they're able to give the relevant response, but when they do not have been trained on given data set, they're not able to generate the given set of response. Okay. So next, what I will be doing, I will be creating a I will be creating a chef kind of related chatbot. Okay, so I'm trying to create instructions of the given recipes and with the response. So this is my data set. This is the recipe 1 and recipe 2, or we can call as instruction 1 and response 1. So with many number of examples, such as which the chef will be cooking, right, the recipes, I will be training the LLM. So then the LLM able to generate better and also able to generate the uh, response, right, which is what can I make with avocados. It able to generate the given recipe and response, but it does not able to respond in generalized way as we required humans, such as let us make a spicy curry. So that is not added here. So we have given instructions to create recipes, but not the other thing which is humans required, human related instructions. So yeah, this is only we can call as instruction fine-tuned LLM. We can call it as this kind of training. Next, we take the chatbot, okay, and we take the human in loop. So we give the recipe. Chatbot create the recipe, cooks food, and give it to the human. With human in loop, humans human able to taste the recipe, and it gives the feedback to the chatbot. Okay, so in the loop, it will get rewards and it will get punishments. So slowly, this chatbot able to understand and able to serve the relevant human those recipes, and those recipes are very aligned with the human. Okay, so this kind of chatbot is called as uh, reinforcement learning with human feedback. these are aligned with human values. And you can see here, so chatbot consists of all these three sets. One is generative pre-training. It's trained on large amount of data. It has instruct and fine tune done on it. And then reinforcement learning with human feedback is happening for the ChatGPT. Then we are trying to create an individual kind of recipe, okay, a chatbot, kind of an individual person. So this we are calling as a grandma, where these recipes will be aligned to this kind of relevant chef only. Okay, so this is called as domain specific or fine tuning specific to given domain or specific task. Finally, there is something where we call it as a rack, which is a block box where there are instructions and context. This LLM will try to extract the query relevant to the query. They try to retrieve the relevant context, and they will arrange them and they will give it to the user. So this is such as facts, grounded facts relevant to the user. You can see here for generative pre-training, we took large amount of unstructured data. It may be GBs. Okay, this is done on self-supervised and this model such as GPT-3 and all. In terms of fine tuning, you need to have a smaller data set where you will be curate the prompts and you will train the LLM. So this kind of training is called as supervised training or instruct tune fine tunings. So this kind of LLMs we can call as instruct tune LLMs. So these are such as instruct GPT, plan, T5, etc. So similarly, you can see here reinforcement learning technique, right? So with human feedback, where you have a smaller data set, which will be having more prompts, generated completions, human ratings, etc. That is the data set. Just a minute. Okay. So yes, this has said this reinforcement learning with human feedback, but very less data set. This is trained on top of generative pre-training, and where we will be doing reinforcement learning algorithm, which is rewards and punishment based on human feedback, and then we will train in the GPT. So finally, we have fine tuning and then RAG. So this is a very fewer data set, which will try to make more fine tuned for the given set of tasks and for the given set of the yeah, for the work you are trying to build. Okay. Next. Okay. These are few comparison between instruct fine tuning and reinforcement learning algorithm, how we are trying to do it. Okay. So now we are going with how you will be interacting with LLMs. So you can interact with LLMs using chat-based interface such as ChatGPT. So just there will be a query window. You just need to type your query, and the ChatGPT will provide you a response. And other ways where you can see here, this is also same, but okay, this is something same, but you can see here one model has 248 million parameters. Okay, it's using Google Flan. So when you have very less parameters, so when you try to give a query, the result is just simple one, which is not a relevant one. But here you can have a model which is better, more trained on larger data set. You can say 7.24 billion parameters. So this is a query, and it when you are you get the query right, so it able to generate a relevant output. So this is using Mistral 7B. So you're able to interact with LLMs using two of the things. One is closed source, other one is open source. So the closed source is such as chat UIs and APIs. This is one is with us. One example is OpenAI, and the other open source is you can do some custom deployments, and or you can use using Hugging Face. Okay, so this is such as like you can in order to custom deployment, you should have your own GPUs. So here in terms of open source, you can also use Hugging Face endpoints for deployment. So for this here, you can see two different things for LLMs, right? Like proprietary and open source part. So one is in terms of a business requirement, you will be only going with the API and custom deployment. So that is what you require. Okay. And then here also there is a GPU requirement will be very important in terms of API and custom deployment. You need to see, figure out how to deploy and what's the infrastructure. Okay? But in terms of chat UI, right? So it's already available with the chat GPT. So for OpenAI, OpenAI API related endpoints, that is GPT 3.5 Turbo. So when you see chat UI, it's chat GPT 3 uses 3.5 or anything else. Okay, next, tokenization. Tokenization is a very important topic in NLP and LLMs while working on. So this topic is very important because whenever you collect the data and you store it, right, so you will be converting the data into a certain format which is relevant to you, and it should be easier for you while retrieving it. So whenever you collect the data, you just convert them into tokens and encode them with some kind of numbers or the vectors. So this is becomes the dictionary for the given set of tokens. For let you have 2421. So this complete set becomes a dictionary. Whenever you try to retrieve the data, you just cross-check the token and you just give the relevant output. Okay, so whenever, in order to tokenize the given data, you will be importing the auto tokenizer from the transformer. So we have been used here bird-based case, that is a tokenizer we have used. So now we are converting the given sentence, piece of sentence into tokens. In order to do that, we are converting first into token IDs, and then we are just converting the tokens. And also you can see here we use detokenizer, decode, okay, decode for tokenizer. So this used to convert the token ID into the given token, okay, and the sentence part. Using for loop, we are again converting the tokens IDs into sentences. So first part you can see the input text, that is less to tokenization. The next part is the length of the tokens. We have 9 tokens. Why we have added this? This is because ls and this separator we have added because to preserve these tokens, we will be adding beginning and at the end we are adding additional tokens to preserve the given sentence or the number of tokens in the given sentence. So these are the encoded tokens, and we are again decoding the encoded tokens into the same sequence. We can get the let's do tokenization, that is a given sentence. So these are very important topics while working with LLM: context length, chat history, and pricing. So for every LLM, when you are right, you are working, you will see the token length. Okay. So what is that context length? So token length is nothing but input tokens plus output tokens. So whichever LLM you are using. So that is its restriction, like that is its the way of giving output. Okay, if you have been you have been giving more context, right? So it able to not generate your relevant output because you are giving more set of tokens to it. So yeah, there should be some restriction in the given token lengths. You can see here LM can only process finite input and generate finite output because of token length. So if you give more token length, so what is happening, there is some kind of memory issue, it will happen, and it not able to generate the relevant context. So because of that, there is some restriction as of now, but slowly with upcoming models such as GPT-4 and newer models with Llama 3, right? So this token size also expanding and increasing. So chat history is something whenever after completing the chat, right? This LLM is not able to preserve the memory of the given chat, so that they will forget, right? So developers need to add chat history into their applications. So this chat history should be memory. It's not with connected with the memory of given queries tokens, right? Because whenever you will be having more and more chat history, these LLMs will able to not figure out what exactly, because you can see here shorter the context length becomes for next input, as more tokens will be used by the chat history. So longer the chat history, it will having some kind of irrelevant effects on the given output. So pricing also depends on number of tokens. Okay, as said, for you can see and observe for OpenAI. So these are the few things here, how you can interact with OpenAI and how you can interact with the open source LLMs. So while interact with OpenAI, right, you need to have OpenAI install, and then you need to use environment, right, install. You need to add the OpenAI API, OpenAI key. So those are the things by default you require. So you can see here we have with OpenAI, the code is very less, right, compared to the custom or open source LLM, because OpenAI has already built something, has said you don't need to train, right? So GPU is not required for OpenAI when you use OpenAI. Okay, so for OpenAI, so just you are adding the model name, you are writing the prompt, and then just you are getting the client, right, for using model and writing prompt and setting the temperatures. That's it. But for open source part, you need to have tokenizer, okay, and then you need to add the GPU, that is important. Then model as usual. Finally, prompt. So prompt is added within some kind of denoted instruction, right? So this is something we are adding instruction, and then we are adding a prompt. So then for open source, we are additionally trying to tokenize. We are again tokenizing from our side. Okay. So also we are trying to use 4-bit quantization. Okay. So for this GPU part, these are few additional things we are doing, and then finally the same, right? But here we are using tokenized prompt here. So here only we have prompt. Then everything is same. Then everything same, and this is the decode part. Okay. Okay. So we are using tokenizer, and we are using GPU, and we are using here tokenized prompt. So these are few things we are additionally using compared to OpenAI code. So how you can interact with chat model? Chat model, you just need to write your question and it able to answer the or generate the response. But we have other thing is code completion or chat completion. So chat completion is something which is generating the only single output for the given query. So this is other way while interact with open AI and open source LLMs. Okay. So here we have done here imported OpenAI and then we loaded our environment file. So this is will be having OpenAI key, right? And then okay, so model is GPT 3.5 and adding the prompt. So row, and row. These are we have added the number of prompts, and then okay, that's it, model and prompt. And then we have used this OpenAI code. So it is able to generate the response. But here we have important tokenizer, okay, and then GPU, model, okay, model, then message. Here this we have prompt. Okay. So same. Okay, next here we have tokenizer. Okay, then we have 4-bit loading 4-bit quantization for like GPU part for GPU to train, right? So we are doing that. And then yeah, we are giving some new max tokens. Okay, as same here. We are doing that same here. Everything is same, but few additional code we are doing with while working on open source models. Yes, that's it from my side. Pratima, you can go ahead.
Yes. So thank you, Yahya, to finishing out to the LLM's topic. Okay, so coming to prompt engineering, the very important information over here is about how you bring out to the prompts. It's where you subject out your input information. So that's what matters on how it would give out to the concise data based on your particular question asked. Types of questions that we could come up with in terms of communicating out with ChatGPT or OpenAI. So the first particular format generally applies out with 0-shot prompting, and a second one being a few-shot prompting, and the third one being chain of thought prompting. So I will differentiate out with each and every particular topic, so you get a kind of a clear understanding of the kind of prompt you are giving out to the OpenAI or Chat. speaking out with a AI tool or when you're speaking out with a chat GPT, you should be in a expressive in such a way that you're generally delivering the output a small kid or person who isn't unaware of this particular industrial or technical knowledge. So it should be much more basic and much more clear so that whatever information or whatever answer you get as a response is more connective or relative to whatever that you had. You could try it out from your end to understand the chat GPT prompt engineering in detail for developers. When you're working out with a prompt engineering, one thing you need to understand is basically a introductory or foundational knowledge in terms of Python. So that is a kind of a key basics that's very important. And if at all you wanted to bring the open AI tool or chat GPT in terms of giving a statement to your Google Colab file, in that case, you need to include out to your OpenAI API key. So which will be helpful in learning out in your own local environment. So you don't have to go out to that particular browser every point of a time to get on to the relative answers according to your particular questions asked. So it similarly works out to the particular information that how you generally give it out to in terms of how what like many times when you give out to any particular query or any particular thing that you are completely unaware of. But the main struggle basically lies out in how you express the information so that AI could understand you very well on what you are expecting from that particular tool. Coming to the open AI APIs, the signatures have changed out in the latest release. So for this particular kind of a release, implemented out are much more inclined to what the current API keys exist out to be. So you need to do out to some sort of tweaks and changes that would make it out in your Python coding environment so that it reflects out to be prompt responses generically. And getting out to the various differences that you could understand in terms of these three topics in prompt engineering. Is my okay, is my slide visible? Cool. Okay, so coming to the zero shot prompt engineering, here we could give out to the information, so that is much more instructive, something in form of a statement which asks out to some particular question. For example, like if you could ask out to any kind of a question in terms of information, some kind this particular information on the neural networks or what is neural network. So some sort of a definition or some sort of where you get introduced to the complete features or implementations or applications of neural network. It's basically a way to understand or get out to all the detailed information, whatever that you had asked for in terms of zero shot prompting, because here you're not training out to the model. So there's no, you're just asking out the question directly so that it gives out to the right prompts according to the query. For example, okay, let me open the slideshow. So for example, if you take out this particular example, like they have given out one particular sentence in German. So, and they're asking out to the kind of a translation, and it should start with F letter. So it should be a pure translation of each and every single letter, but each and every letter should start with F. For each and every letter so that it reflects out the information starting with the letter F. So that's the kind of a clear cut information that's given in terms of zero shot prompt. Coming to a few short learning, here in this particular case, you're training the model. You're getting them understand in terms of examples, in terms of some scenarios to that you expect it out. So you can give out to some sort of an information that, okay, if you have some sort of mathematical formulas, some sort of statistical formulas, you just give out to this particular formula saying, "Oh, these are the values, this is the kind of information that you would like to do it out, some kind of variation analysis that you would like to bring it out in form of outputs." So in that case, we generally prescribe out to all the particular use output, you generally get it out for that particular example or scenario. You're teaching it out with an example so that it understands better. And since this is not a reinforcement learning, you don't have to do out to a training and give on to the rewards and everything. You just give on to the relevant information to help it understand using an example or scenario, and then get out to the relevant answer with the kind of a question you have. For example, if you see out to this particular question, you have given out to each and every particular information, like each and every food item and that respective euro dollars. They have given out to respective information. So according to that, they have given this particular steak has this price of 24.99 US dollars. So what is that going to be in terms of cent or in terms of dollars, or how you want to reflect it out in terms of currency? So information, input information is basically in type of text, textually written, and when you reflect it out in terms of output, they are given it out in terms of a euro representation of that particular symbol. So it just gives out to a short inputs so that it understands what it should generate. So we teach it out, we express what they need to provide it out to us. And the next particular prompting engineering is chain of plot prompting. So here is basically like you're checking out to the memory of your chat GPT or some sort of historic information. Like there is a few set of things which has a lot of history or which has a few set of detailed process that you need to understand it. So if you ask it out in a form of a generalized question, they generally can't be able to express three sentences, but that generally doesn't give out to the complete outline information of how it worked out or how it generally started out, giving out to the complete analysis from the very point of a time it originated. So in that point of a time, you like overlapping it out with a chain of thoughts. So if you start out with one particular origination, it will lead out to another particular information. Similarly, going on and on until it is reflecting out we had asked out to the question. So it's like a working memory that you could give it out. So for example, if you see it out, the who won out to the World Cup in year before Lionel Messi was born. So before it's born, you need to think of when the particular person was born on that particular year. And before to that, when did World Cup took place? And based on that, you can realize that is the kind of country something which you could do it out, but if you wanted to get out to the information from OpenAI or ChatGPT, you can easily do that if you're completely unaware of the information, because it's not that everyone knows how to everything. So it's basically an easy kind of a tool that you gain out to easy access, or some sort of things that if you don't want to deal to a practical complex problems, you can just give it out in form of a scenarios for it to understand and train it. And so this is a kind of a way how the prompt engineering works, and that is a way you could make it much more prescribed according to what kind of a questions that you are asking. So once you are completely sure that this is what you want, so accordingly you can ask to be that particular reflective question, and it makes your communication with AI tools pretty simple. So once we basically help you out even in constructing out to a AI models, giving out to a better informatory information directly into the Jupyter notebooks or into the files, where you don't have to mingle out to all the kind of hustling, juggling out here and there to complete out to the respective problem statements. So this is one topic that is going to be really helpful in your career. So yeah, you're mute. You're on mute.
Yes, thank you, Pratima. Today we have been going with the basic topics of LLMs, how we can interact, such as with APIs and custom deployment, right? And then we can have also gone with the tokenization and how this LLM being trained on large data and what the techniques are used for building LLM based application. We have been called right again. So yeah, tomorrow we can go with few in terms of working with code
Yeah,
and
yeah,
getting
just a
more into
moment.
the
I would like to add something here.
sure.
Everyone, thank you once again for joining out to today's session. Tomorrow it's going to be much more interesting because Krishna sir is retrieval, augmented generation, and the framework how it generally implements out to be. So that definitely turns out to be very interesting. And coming to the information with respect to this particular sessions, we will be providing you all with a participation certificate for joining into this particular sessions for 2 days. So yes, tomorrow I'll share out to the registration. You'll be getting certified in this particular topic of building LLM applications.